Hey everyone, I'm David Room, and we're going to do a little project update today and some live coding. I figure as long as I'm working on my project, I might as well stream it, uh, give other people a chance to watch, listen, maybe an excuse to work on their own creative work, hang out, have a little company. I know that's how I like to use other people's streams, so trying to pass it on and do some of this myself. Um, so two main things I wanted to do today. I am making some really nice headway on my low poly procedural or programmatic humans effort, and I just wanted to show that because I think it's really cool, and it's a little hard to convey what it's all about just with a screenshot on Twitter. So I wanted to show some of that interactively. And then the other thing that I want to do is do a little live coding, because the other day when I streamed, one of the tasks was looking at uh, sort of a work log and developing a list of content that I want for my finished game. I'm building a space combat game, and I need a few more ships than what I have, and I have an idea for a nice, simple fighter ship design that also might scale and be able to do some different things, or lend itself nicely to some variants. So we're gonna try to bang that out tonight and see how far we get with that. And I've been trying to put my it's good to put myself on the spot with some of the live coding stuff because it helps me stay sharp and focused, and um, also uh, also it's good as I build out this functionality and want to make sure that it's easy for me to create new things, to test it out by actually putting myself on the spot to see, okay, can I actually create a ship, beginning to end, for my game in an hour or so. So that's what we're going to try to do. Let me just check and see. Before I get into anything, I'm just going to share a link on Twitter here now that we're live. Live now, coming out. And all right, so a little bit of a recap for people who maybe are just tuning in. I don't know too much about my project. I'm building a sort of retro-styled, low poly space combat game inspired by games like TIE Fighter and MechWarrior 2. But with some distinctive features like real, like more correct Newtonian physics, and maybe hopefully a little bit more personal story than those games. And to that end, one thing that I really want to have is actual human characters. Now, the way I'm making the content for my game is a little bit different than the way I think most people would approach this. And that is that I am making all of the content for my game programmatically. You could maybe use the term procedurally as well. You hear about procedural content generation for games like No Man's Sky. I don't usually use the term procedural because I'm not trying to randomly generate a whole bunch of content from my game. I'm just using code to generate the content rather than a lot of like manual modeling with Blender. So all of the ships and geometry and planets and different assets are generated with code. And I wanted to do the same thing for people. Now there's a little bit of procedural element here too, because the idea would be that you kind of have these methods for creating people, or human, human figures. And with people, there are a lot of rules and proportions to how faces look and how bodies look, but then there's little variations. So I'm trying to build a system that makes it easy to sort of create these custom variations, and be able to do things programmatically, but still create and kind of hand tune different characters that I want. So, and I've made some really great headway on this. So, the initial work to this started back in the beginning of October, and I think I showed a little bit of this last time. Started out by kind of procedurally or programmatically laying out different facial features, and then basically triangulating between them, offsetting, kind of doing different things in 3D, constructing different parts of the head, and then the sort of first proof of concept application that I wanted this for the game was wingmate animations. So I kind of roughed out a helmet and a little cockpit, and got this into the game as this wingman animation that shows up when you give wingman commands. So that was sort of the first application of this. What I want to have characters that you can interact with at different parts of the game for story cutscenes and stuff. I'm not planning on doing anything crazy with animations or anything like that, but just having some human faces, I think would bring a lot of life to the story of the game. So that was the initial work. I've generally was working on other things for the past while, but I've kind of picked up this effort again lately. And the first, like the main thing that I was trying to do here, and my goal was being able to create, I have sort of this general method for creating a low poly face, and it's, nothing set in stone. I'm going to be tweaking this and everything, but I've got this general method. Now I want to start making specific characters. So I want to be able to start, tweaking the parameters and creating these different specific people. And it seems like the first thing that I'd want to do in terms of being able to differentiate different kinds of faces would be being able to adjust the shape of the jaw to get male versus female characters. And the first thing that I ran into when I started doing this is that the shape of the face that I had didn't lend itself to doing that. I have this outline set up where I have a point at the bottom of the chin. So what ended up happening is, like, you couldn't tighten the bottom of the chin very much, because you'd have this point in the middle, and then you'd end up with this little, like, divot shaped chin. And for a female chin, you want to be able to have sort of a tight chin shape without that extra vertex in the middle. Actually, if I can bring this up, I found some good references here. Let's see here. So I was looking at how some PlayStation games did this. So, whoops, yeah. So here's Squall from Final Fantasy VIII, and I'm going to apologize because I'm using MeshLab here, and I'm not too familiar with the controls of MeshLab. But you can see his face. There's no central vertex. There is this two vertex sort of flat shape at the bottom that gives a nice shape to the chin. And he's got a texture too. My characters are not going to have textures. I'm going to do I've got more of the details modeled out, and I'm going to do some details with vertex colors. But just in terms of the general shape, I think that that sort of two vertices at the bottom of the chin looks really nice. So that was one of the first things that I changed. And then with this change, you can see that you can start to get a nice differentiation between male and female. And then I added a couple more features. So being able to tweak the width of the lips and the height of the lips and the width of the nose. So the width of the bottom of the nose I had kind of previously keyed just to match with the corners of the eyes, but adding a scale factor on that to be able to bring it in a little bit, and then also widening the upturn of the nose a little bit for the female character, and like adjusting the size and scale of the lips too, I think really helped differentiate the two. The next thing that I did, and I just did this the day before yesterday, was the first pass at ears and eyebrows. I found a nice function that I can use to get this eyebrow shape. It's a little cartoony. I'll probably come back to it later, but I think it's a good first pass for now. And the ears are just a simple outline of two different sort of arcs of a circle with a border run around them, and then angled with a few different angles and kind of stuck in the sides of the head at the width, which is a parameter. And then today, I got some other really nice stuff going, so I'm gonna just run this interactively. I split the eyeball into 3 separate pieces, so I have a white, an iris, and a pupil. And then I came up with a simple method for doing hair that I think works pretty well, and I had to build a new set of tools to do that. So the end result looks like this, which I think looks pretty good for a first pass. Basically what I'm doing is I just have a UV sphere. I kind of slice it off at an angle. I add random amounts to each of the points that's up against the slicing plane, so you end up with these spikes. And then I wrote up a sort of a heuristic-based iterative method for adjusting the planes, or the triangles of the face, so they have minimal overlap with the underlying head mesh. So I first take everything, project all the points down onto the head mesh that's beneath it, and then I do this iterative tweaking to try to pull things off. And this isn't perfect, but it seems to work pretty reliably. I have it set up right now so that actually I'm not seeding the random number that I'm using for these adjustments. So if I run this again, we should get a little bit different hair. And I was doing this while I was testing it so that I could see and kind of make sure that it wasn't just coincidentally working, but it was actually, doing something consistently. So you get some variation. I exempted the ears from the collision checking so the hair can overlap the ears. I think that looks kind of nice. And then gave it an intense smooth modifier. And I think with all this stuff, it really is starting to look like I want it to, like an actual person. Michael Kane is stopping in. Hey, Michael Kane. So yeah, this is my low poly person that I'm working on. And then I was excited this afternoon because I figured out how to add color attributes. I just did this manually, so I can't really show you interactively right at the moment, but I added color attributes so you can see this is roughly how it would look in the game, because I have a very simple kind of classic shader set up in the game with specular, and I would probably start with solid colors, although we could give a little variation with vertex colors to give a little skin tone variation. I think that probably would look nice. But I think the eyes especially look really nice. And I think it would be pretty straightforward to animate the eyes. So that's something that I'm looking forward to trying. There's a few other things there's some kind of unsightly creases here at different parts of the face. Some things to be worked out there as far as how I'm handling that. There's some different solutions. Then I had to manually ding around with the eyebrows to get them to not intersect the face. So there's still some work there as far as coming up with a reliable way to set up the eyebrows. I've got some ideas about that too. But I think this is a really good start, and it's like, oh, this is starting to look like something, like starting to look like what I was picturing in my head. So I'm pretty excited about that. I think like overall it looks pretty nice from different angles too. Like we have a decent profile. I'm actually gonna get rid of the hair for now. Decent profile, and a lot of the things that are a little bit wonky here are actually tweakable in the configuration. So I have configuration for like how much the chin comes out. Can probably experiment more with the neck so I don't get this kind of unsightly jaw intersection here. Like I think if I scaled the neck down a little bit and maybe like moved it a little bit, that looks a little bit better. There's some other things we could do for the neck as well. And there's probably different things we could do with the ears too, but I think this is a good start. And they should be roughly positioned right. We could tweak them and kind of backport those tweaks into the code defaults, and I think it looks pretty good though overall. So yeah, the next step, and I'll show a little preview of what else I'm working on here. The next step is getting these attached. I have these low poly rigs, or not rig. I have rigs and low poly bodies, and the these have some issues, of course. This is the free human reference model pack that Blender comes with. So you can kind of see I'm not terribly far off in terms of proportions here, and I can tweak this, but this is just sort of basic meshes for some of the different body parts. I have a lot better tools since when I made this originally, so I think we can come up with something better now, and we'll work on parameterizing this soon for male versus female characters. This is obviously a much more realistic head. This is more stylized, but kind of in the right right ballpark, I think. So Doug Wise asks, how much people are you imagining in the game? First instant made me think of Kerbal Space Program, which is mostly just faces and facial motions. Yeah, so the game is going to have a story that involves maybe like a half dozen people. So the story of the game is basically this angelic being recruits a bunch of people for his kind of long shot suicide mission that involves a bunch of space combat. So it's kind of like the classic, a few people that you're hanging out with and developing relationships with aboard the space cruiser. So mostly there's probably not even gonna be too many facial animations. It's mostly just I want models so that like when you have a cutscene where a couple people are talking to each other, they can be standing there looking at each other, and then the cockpit wingmen animation. So when there's interactive stuff in the game, story type cutscenes, I want to be able to have the actual characters there. And it'll be specific characters that I'm creating, not just procedurally generated random characters. They're going to be actually people with their own backstories and things like that. So yeah, so that's the progress on the low poly humans. I'm pretty excited about. That was one of my things for the end of the year. Start differentiating characters, get male versus female faces, get heads on bodies. So I'm pretty excited about that. I've got my Panera Death Lemonade here. I was doing some work out of the house today with my sister, and she was at Panera, so I thought I had to try the Death Lemonade. And my biggest reaction to it is that it's really nothing special. It's not very sweet, so I think maybe that's why it's catching people off guard by how much caffeine is in it, because you could probably drink a lot of it before you got sugared out of it. But as far as the caffeine content, I don't feel like it's anything special. As I was drinking it, I didn't feel super buzzed or anything like that. So I'm a little bit disappointed. I think it would have been fun if it would have had that sort of extreme caffeine effect like nitro or something, but it's pretty normal. Okay, so the next thing I wanted to do here is I wanted to make another ship. And we the other day we looked at the lineup of the ships that I have for my game, and I kind of came to the conclusion after looking at the TIE Fighter manual, which is sort of my reference for the content that I want to have. I just need a few more ships. So I started thinking about different designs, and I'd seen some really cool designs the other day on Twitter, and I thought it would be neat to try to do a design that's kind of inspired by one of them, because it's not something that I've done yet, so it's something that's a little bit distinct, and I kind of want to try to put my own, or do my own take on it. So let's see here. So this is the design that I saw that kind of inspired me. It is a 3-sided design that has a really simple shape, this kind of triangular design, and then at the bottom it narrows down to sort of a hexagonal shape. And there's a lot of things about this design that I'm not going to copyright. I'm not copying this design. I'm kind of taking it as inspiration for something. This general shape is kind of what I'm looking at. For my ships, my ships don't have rocket engines. They have these sort of magic drives. So it's not going to have a rocket. It would actually probably have 3 of the drives at the back, and the radiators would not be at the front like this. The radiators would be at the back. So that's going to be 2 really big things that will be different about my take on this. And I was going to try to find the person who shared this, kind of shared it with a whole bunch of his 3-sided designs. So I wanted to bring those up and talk about so this is it. This Zando Arts guy is a really great follow if you like cool space art. His designs are more realistic than mine, but it's kind of a similar aesthetic, and I really like what he does. So he's got these neat trilateral uh, trilateral symmetry designs that he shared as well. So I have something kind of similar to this already. So I have a couple of three-sided designs, but they're both ships that are a lot bigger. So I have this ship, which is technically like a yacht. The idea with this ship is that it would have a lot of windows and kind of a big, sort of uniquely laid out living area compared to a lot of other ships. So it would probably make the most sense as a yacht, and it's got a sort of trilateral symmetry here. The drives and then the radiators kind of behind the drives. And then I have this freighter, which is an older design of mine, which also has the trilateral symmetry. But I don't have anything that's trilateral that's smaller, like fighter sized. So that's what I wanted to try. I wanted to try a ship that's kind of the size of the little fighters, but has that kind of the same rough body shape, simple three-sided body shape as this. So, and I think with the tools I have, it'll be pretty simple to write it up. And I want to, write it up, get it in the lineup with these other ships, start looking at it kind of side by side, start thinking about it. Jeez. Sorry for the whiplash there. Start thinking about it alongside these ships. But another thing that I want to do is I think that general body shape would also sort of, because it's such a simple shape, it would scale up really well to a larger size. So when I'm building this design, I'm going to do maybe a little bit more work than I usually do to parameterize different parts of it. So I might actually be able to get a couple of different variations out of it in terms of different sizes of ships. Not just variations like some of these where they're different weapons or different things, but actually like different proportions, different scales of that same shape. Because I think it's a really cool shape. I think it's kind of an obvious shape once you see it, and there might be some nice possibilities there. So we're just gonna dive in and start writing that up. I'm probably gonna work on the mesh first, but then I'll pivot over quick, try to pound out the pieces as far as getting it into the game as a ship, so then we can see it in this lineup, and we will go from there. Okay, YouTube was giving me some warning about stream bitrate. I'm gonna just quick double check on what it looks like on YouTube for me, and then I'm gonna jump into this looks fine. Then I'm going to jump into the live coding. Okay, yeah, everything looks fine. I'm not sure what was up with that warning. I'm still learning about all this stuff. I thought I understood how OBS worked with profiles, but I think I was confusing profiles with scenes or something, and I ended up deleting all my inputs. So that's why I was late today. Is I had to I had to recreate my my scene layouts. Should figure out how to back those up too, so that doesn't happen again. Okay. And I'm going to get some music going here in just a second too. It's always fun to close the close the Blender without saving, because everything is just generated by code. I don't need to save it. All right, and let me know if the music is too loud at any point. I can't tell how loud the music is compared to my voice. It would be fun to be big enough that I could just sort of not care about copyright infringement and just stream whatever I wanted. But for anybody who doesn't know, there's this guy called Carl Casey who does royalty-free music that you can use in your stream without permission. It's great stuff. Okay. And I don't have a particular name in mind for this ship, so we're just gonna call it jeez. Okay. We're gonna just call it a drone for now. It's partially going to be a drone because I don't know exactly where the cockpit would go in this design. And I definitely need to have some enemy ships that are drones, because manned fighters don't necessarily make a ton of sense in my world, except for the reasons that, the sort of like magical reasons that we'll be getting into in the story. So a lot of the fighter ships that will be encountered are going to be drones anyway. So we'll start by just making a new Python file, and we'll call it we'll just call it drone. Doing some testing here. This bench file, it's like my workbench where I can invoke different scripts. It's a bunch of junk in here. So we'll just set this up to view a set of parts that will come out of this drone script. And I give everything LED. And we'll copy the imports from one of these other modules, just so we're not constantly having to look up the stuff that we're importing. Michael Kane has a great question. He says, have you ever seen the game Chorus? It's not really great. It's really arcadey, but it combines some occult type stuff with space fighters. I didn't finish it, had some fun, but got distracted with something, never went back. Yes, so I was thrilled when I saw the trailer for Chorus, because it is very rare to find comp material for sort of occult space type stories. It's just not super common. So I thought it was really cool to see that game, because it was like, oh, this is kind of like the kind of story that I'm trying to tell. And I downloaded the demo for PC when it came out, and I played through a little bit of it. I really struggled with the controls of that game. So I don't think I even beat the demo. I maybe played it for like an hour or so. I need to give it another try. I might actually spend a little bit of time with it sometime soon. I really like the art direction in that game though, and the general feel. The trailer was awesome. I loved it. Okay, so let's just make a quick part set that you can return here. And then the way I've been trying to do these is I parameterize a lot of things with constants in the module level. So that makes it easy to sort of tweak the dimensions of things to try to get things to match up in size. So we'll do that here. Michael Kane says, I didn't, it was a lot better with the controller, not a good keyboard and mouse game. Yeah, that was kind of the impression that I had, but for whatever reason, I just never got around to, trying it with the controller. So yeah, let's lay out a few constants here. So, and I'm just going to look at the needle for comparison. So the needle is the other sort of small fighter here. It looks like it's, yeah, it's about 20. Is it really that long? Some of these are tricky because I sort of build them at one size and then I scale them down. Yeah, I'm scaling it down. Okay, so the needle is like 15 meters long. Let's see if we can get this the right size without having to apply a scale after. So we'll say the total length of the fuselage will be something like 15 meters. And then the radius at the tip will be like 1 meter, and the radius at the rear will be something like 3 meters, and then the radius at the center, or the part where the front meets the rear, will be, actually this is probably too big, it should probably be more like 2. maybe 3.5, 3. We'll see. So, yeah, Michael Caine says, I like some of the ideas for the powers that you gain, but I wish they had been a little weirder. Some of them was hard to see why they wouldn't have just been technological instead of magical. Yeah, and you know, I should probably spend some time just looking at that game just to understand what they did for reference for my stuff. Because I definitely don't want that. I want the magic stuff to feel very wildly distinct from the technological aspects. Okay, so let's get this fuselage built here. So the way we make parts usually is constructing them from what I call ribs. So we have these 2D polygons that we stack up and then connect together with triangles. So we're going to do that here. So we might eventually do this in a couple of different pieces, but let's just take a look here. So, and then the center of gravity is going to be at that point where the long sort of nose of it comes to meet the rear. And I think that should probably be about at 10 meters. So, okay. And let me just throw up something here, and then we can start running and iterating on this. So, so we want swear I can type. And okay. Yeah, and this I actually want to be. So this is just the offset of like how that rib is going to be rotated, and I want to have this laid out so it's sort of two, like the plane of one side facing up to the top, because I think that looks the most menacing from the front. So tau divided by 4. Okay, so that'll be the tip nose, and let's give this a little bit of a bevel. Let's see here. One nice thing about using actual meters, right, is that you can kind of picture things. So if our radius at the tip is going to be 1 meter, actually this should probably be more like half a meter, 0.75 meters. You can picture, we want a bevel of 10 centimeters or something on it. Center is going to be quite a bit bigger, like half a meter, 1/4 of a meter, and then the bevel at the rear is going to be a significant fraction of the actual rear radius. And we'll tweak this later because we might do this a little bit differently, but we'll start with doing it this way. Okay. Call this nose instead of tip. Okay. Let's see if this looks like what we want. Oh, I need to add. Forgot to add the Y values. Duh. So this is going to be at front. Actually, this should be nose. Center will be at 0, y equals 0, and then the rear will be at fuse length minus basically the remainder, but negative. Okay. Whoops. Yeah, okay, so it's sometimes hard to picture how big things are, and rad rear. But that's not a bad start. Yeah, so this needs to be quite a bit bigger. And maybe the rear bevel can stay about the same size. Yeah, okay, so this needs to be even bigger. But yeah, you can see this is basically what I was hoping for. Actually, yeah, okay, let's just go big. And then instead of beveling the rear from a triangle, I am going to just make a 6-sided polygon directly for the rear. So we'll do thread rear. I think we can use the same offset angle. Let's see. Nope. No, we can't. 0 work here? Nope. Okay, I've got to plot these to see what's going on here. The problem here is I've got two shapes and they don't match up. So I just need to roll one of them so that it lines up. I could also calculate what bevel it should have to be a perfectly six-sided polygon, but I don't feel like doing that right now. Yeah, so it's six-sided because it's like a triangular shape at the front, and then it bevels. So then the rear is going to be like a roughly six-sided shape. Like if we go back to that original kind of design that inspired me here, you can see at the cone at the back it's more of a even six-sided shape. And I think I don't know what the reason in this guy's piece for it being trilateral would be. The one functional reason, and this is what the reason for it would be in my world, would be that you could basically get most of your maneuverability out of 3 drives at the back. So you'd have like I think they call it like a delta configuration when it comes to like robotics. So you basically need 3 degrees of freedom to describe like how you'd aim something, right? So with 3 drives you could get that control to have a 3D vector point where you want. Most of my ships I've done so far, at least the smaller ships, have like 4, or they have other thrusters or things on other parts of the ship. And this ship might have other thrusters too, but it would have 3 equally sized main drives. So it should be like pretty maneuverable as far as yaw and pitch and things like that. So let's take a look at what's going on here with these. Okay, so that looks basically like I want it to look. So we just have something that's not lining up as far as where the numbers are. And I could actually find a correspondence here too, but we can just look at it and see. Okay, so here 0 is down here, and here 0 is up here. So it looks like we just need to roll things backward by 2, and then it should match up. Let's see, would it make sense? Yeah, okay. So we should be able to do this. P.roll. And I think this should take axis. Shift equals -2, axis equals 0. So just for people who are following along with what's going on here. So all of these ribs are described with 2-dimensional NumPy arrays of points. So I can manipulate them using NumPy. And here, to get the coordinates to match up, corresponding points to match up, I'm just shifting, and roll is a NumPy function that shifts an array along a certain axis, and then like the points that would get shifted off the end get popped back onto the top. So I think this should actually solve the problem. So here 0, 1 here. Oh, wrong direction maybe. Oh yeah. Yeah, there we go. Okay. Yeah. So this is what I was picturing here. So we have this kind of triangular shape at the front, comes to sort of a nice narrow point, and then we have an even-sided uh, six-sided shape at the rear. And I think what I'm actually going to make this a little bit smaller because I want room for the edges of the drives to sort of poke more above the edge. So we don't have to hunt around for constants in the different code that we're using. It's all up here. So we can change this to 1.5 here. And we might as well get this into the parts here. So fuselage equals, so we'll add this as a part. Ship, it's root, fuselage, and then the next thing we're going to be adding is some drives. So let's try to add those. I'm imagining these drives kind of embedded in the rear section of the fuselage. We'll see how that looks. Doesn't always look quite right to do that. They might need little supports as well, but that's pretty straightforward to do as well. Okay. I'll just keep things really simple here without any extra parts. And let's see here. So for index K in actually, I've got a function. I wrote a function that does this. Where was that? Is it in parts? Oh, let's see here. Model prefix, parent count, axis function, offset angle axis. Yeah, that's what I want. I build these things and then I forget how they work. Okay, so parts.spin. Parent root. And there's going to be 3 drives. Count is 3. Offset angle. That's also going to be that angle offset, I believe. And the offset, I think, is the, yeah. That is the just coordinate offset. So that is going to be, oh, let's see here. So set them back -2 from the center. Center equals 0. So 0 for Z. So now drive, we just need to make the drive mesh, and there is I have a chamfered cylinder that I use for everything. I need to rewrite this at some point because it's kind of silly how it works. Yeah, that's in kit. So kit dot chamfered. So this is going to be our length, our radius, and let's see, drive subs, and our chamfer amount will just make that a normal amount. So let's see. Zero. Okay, what am I missing here? Oh, axis func. See what parent count axis func. Axis func, and I forget what this was. Axis func. Oh, that just gives the rotation. So that's just going to be rotation y. Okay, because see, the idea is then that axis function transforms the offset as well. That's kind of the, yeah, that's really the meat of what this function is doing. So you don't have to keep writing that yourself. Oh, prefix. Let's see, where does that go? Model prefix. So prefix is going to be drive. Right. Oh, don't need that. Okay, let's let's take a look and see what this looks like. Yeah, okay, so not super far off. Just need to bring these out a little bit farther. Can get rid of some of this plotting stuff. Yeah, now let's see, does this make sense? Yeah, because if these are 4 in length, if they're off 2, then they're going to line up exactly with there, and that's not what I want. Oh, and I don't want them on... Yeah, I don't want them on this side either. I want them on the side that's sloping in. So actually... Oh, wait just a second here. My angle offset is not what I want here at all. Um, okay, I'm actually going to get this into Blender just so I can see it and just make sure I'm not seeing what's going on wrong. Oh, no, it is actually correct. I just want... I do want the same... I'm confused now. Plus. Yeah, there we go. That's what I want. Now, these need to be bigger. This needs to be smaller, and they need to be moved farther back. So let's do that. Yeah. Okay, this is starting to look like what I was picturing. So, but these could actually come out. I want these actually to come out a little farther. Something like this. And they can actually be a little bit... Yeah, these should they should actually be a little bit farther back even. So I am going to probably want some kind of support structure for them. Okay, so for 2.5 and so we can just make a drive support here. See here. Actually, no, that's the Y. The X is something like drive X off times 1.2, and the Z is like the thickness of it. So we'll make another constant for this. Thick. And these is kind of going to be an identical call to this. See how this looks. Do this right. Nope. Oh. Almost. So I need to just shift them back. To be half. Let's see here. Instead of the offset being out here, I want it to be halfway out. So half the offset. Yeah, that's close enough. And these are colliding right with the edge. We don't want that, so we should shift everything forward a little bit. Actually, this shouldn't be drive X off. It should be, let's see, drive X. Okay, oops. And then this 3.5. Yeah. Yep. This is basically looking like what I wanted. Now, I'm just thinking about this a little bit here. I might actually now that I'm looking at this, it might actually make more sense to bring these in a little bit. No? Just thinking about having room for the radiators. So I don't want the radiators like radiating right into the drives. Obviously. In that sort of reference design, he had radiators at the front of the ship, but you know, the reactors in my ships are more typically towards the rear, so the radiator should come out somewhere like in here. So I don't want them interfering with this, but I also want to, let's see here. This is the interesting part about not sketching this out ahead of time, which is what I should have done. Like, how can I keep the sort of clean look of this Because I like doing these low poly designs because you can kind of think about the basic shape of everything. And make sure it's sort of what you want. So I don't want radiators at the front. Yeah, you know, so that's a good point, Doug. My radiators, I haven't exactly worked out exactly how they work. My current sort of working assumption is that there's probably different kinds of radiators. So like for interplanetary travel, there's kind of like a different set of functionality that would take over. And in that case, those radiators probably would dump heat into another dimension, because they'd be operating. There'd be much more waste heat, much more energy being generated in general. Different rules, kind of related to some of the magic nature of the drive, start to take over. For fighters, that wouldn't be the case. And in general, like, even if the radiators are sort of dumping heat into another dimension, they shouldn't be really obviously like radiating right into another part of the spacecraft structure. That was a problem with some of my initial designs, is I just wasn't thinking about that, so I made stuff that didn't make sense, and I'm kind of reworking some of those designs now. I'm just thinking about what do I want to do with this design, because I could add some kind of like offsets here that would get the radiators clear of the drives. I could also bring the drives further in, but in my designs, I do like to have at least generally some kind of open space either around the drives or in front. And I'm leaning more towards designs that have open space, or at least, you know, some open space in front of the drives. I don't want to bring these drives out much farther though, because I want to keep this kind of narrow. You know, I think probably the simplest thing I could do would just be to bring the drives in a little bit farther, then do some kind of offset here that raise the profile of wherever the radiators were coming out of. I think that's probably the simplest thing to do. So let's go that route. Okay, so we'll reduce this. And then we'll try to come up with a yeah. Because I have other designs where the drives are sort of buried in the ship. Doug Wise says tail fins on the offsets. Yeah, so I'm kind of picturing something like this. Let's see if I can sketch it out in Blender. This would be a good exercise. Let's see here. So look, something like this. Whoops. A little bit rusty with Blender here. Oops. And then if I take this, inset, extrude, and scale in. So I'm kind of picturing something like this. How does that look? That kind of... Whoops. That kind of breaks up the nice design though. The other thing that we could do, and this was the other thing that I was thinking about, was adding sort of a central section and having the radiators come out of that. And that actually might be a nice choice too, because it would also sort of differentiate it from my reference material. And it would let me keep this nice, the cleaner sort of rear section. Let's try that and see how that works, how that looks. Okay, so we're gonna try something else here. So we'll bring this back. So now we'll have two center ribs. So we'll have a center length. Don't need this overall length anymore. Yeah, I think this is going to work the best. And it's also going to make it look less like a old-fashioned rocket and more like something kind of distinct, which is what I think I prefer. Yeah, that's I like that. And yeah, you know, we could get, there's some different things. We could get away with this, the rear section being shorter now, and this middle section could be shorter too. We want to kind of have, there's like some design rules that say you should sort of have big, medium, and small parts. And I think these parts are sort of too close in size to each other right now. It looks a little awkward, so making the middle section narrower I think is going to be better than making the rear section narrower. So we'll make this 2. Whoops, wrong constant. Yeah, that, I like the look of that pretty well. And you know, now I think we could actually, yeah, okay, I've got another tweak that we can make that I think is going to look good. So we can increase the drive offset now to the point where the drives are fully clear, which is going to look Nice. Let's see here. 2.7, I think we can do. Yeah. Nice, kind of simple design, but this is going to have quite a distinct silhouette from my other stuff. And actually, a couple other things we can do here. So this does need to be a little bit bigger. And then I want to do these supports a little differently. So I want to do some trapezoids instead. So I forget all of my trapezoid. Solid.solidify. Solid. Let's see. Solidify. Solid. Rib. Slope. No, that's not what I want. What is the name of that function? I've got a function that does what I want. That's it. Solid, rib, chamfer, chord. Maybe that is it. Okay, I've got to look at one of my other ships where I use this because I know I've got that's it. Yeah, okay. Okay, yeah, that's what it is. I was I was looking at the right one the first time. Okay, so solid from rib, chamfer, triangulate. So this is going to be a trapezoid now, where we are going to do and support X. And then we're gonna have to we're gonna have to rotate this back around to be where I want it to be, and I can't quite picture in my head where it's gonna start, so we're just gonna have to look at it. Oh, come on. Actually, we just want this one. Thickness, there we go, thickness. Okay, and let's just take a look at it. Okay, so yeah, we want this. So here we have X, Y, Z. We want this to be rotated 90 degrees around Z and then 90 degrees around Y to be in the right position. Support. Yeah. Okay, and I want yeah. Okay, that looks a little bit better. So now, yeah, now we can tweak things a little bit more. We can bring those out a little bit more and forward a little bit more. So yeah. Nice. Okay, so now what we can do is put radiators here on these sections at opposite angles from the drives, and that will look sweet. We can even sweep them a little bit, or do different things. You know what? I think actually, I think this middle section could be, I think this could actually be wider and it would still look okay. Let's see here. Yeah, I think it can be wider. So let's pop this up to 3. Okay, and so now, and this is easy. So the radiators will be right at y equals 0. So here we go. Let's have radiators. And our y offset's going to be 0 for these. And Okay, so let's see here. I think the radiators shouldn't be very big on this. So we'll do something like 2 for the length. This is 3, so we'll do 2 for the width, and then something like 0.1. And then our offset. The radius, let's see here. This doesn't have to be exact, so we can eyeball this. It's going to be something like 1.5, I think. Oops. Not big enough of an offset. Not nearly big enough. Let me see here. Let's see here. Yeah, 0.75. Let's see what this actually needs to be. So it's nice being able to interactively tweak things in Blender. So yeah, it needs to be something like 2. Let's do 2.2. I could derive this too. That probably would be a good thing to do, but I don't feel like doing that because it's after 11 p.m. I think we can do 2.2, and that makes it so there's not too much overlap. Whoops. What happened there? Oh. There we go. Okay, so this is really interesting looking. I can't say I really like it, but it's a starting point, right? It's a starting point to think about. You know, one thing might be putting the drives forward. Longer radiators might also look cool. Just trying to think what this thing is going to look like at different angles. It's got an interesting outline. I think the thing that I am not liking is these. Now I do have other designs where the front of the drives is more buried. I'm thinking that that's what needs to happen here. And I can still keep the supports, they just need to hug. They need to hug this tighter. Yeah. Okay, that's what we need to do. So this will be clear and something like So I want to get rid of that little gap there. So actually, I heard a piece of advice that said always go too far, like make a design too extreme and then dial it back rather than trying to dial up to it. So we'll try something here with these really buried. You know, that that looks pretty cool. I think I like that. Yeah, then it's got a lot sleeker of a look to it. The idea with my drives is that they work something like actual jet engines, where there's like this sort of invisible dimension that sits behind space that they sort of pull through, kind of like a propeller or a turbine or blades, except instead of blades that have like surfaces, there are a whole bunch of mechanical relays that move really fast that create this sort of like entropy braking effect that causes this effect. So in some of my designs, the drives have the front open, so the idea would be like it might be like easy for them to like have some kind of inlet. Dugwise, this would be distinctive to have inlets then, yeah. But I have other designs where they are kind of buried, and certainly like the smaller thrusters just sort of sit in like in the side of a ship and face out, and it might be kind of an efficiency thing too, right? Like you can't have these drives be like perfectly unobstructed, right? Because you have to have some way for power and stuff to get to the different components that are inside. And it might be, in universe, it might be kind of a design trade-off that you can make as far as the other properties of a design versus how unobstructed the drives are. There also might be some other sort of magic stuff that you can do where you could counteract that the effect of having sort of a blocked inlet with other devices. So I think, so let's see. Yeah. So Doug Weiss says, did you suggest this could be a drone that might point towards a bolt-on, bolt-off look? What do you mean by bolt-on, bolt-off? I'm not sure I'm familiar with that terminology. Yeah. So like the like here you have like this region is kind of clear. For sure you'd have a sort of outer edge that was unobstructed. Oh yeah, easy to access everything from the exterior. Yeah. Yeah. I've thought about different designs for these drives too, because the idea would be that they'd have to have electric motors that sort of spin stuff inside of them. And I've experimented with different designs, thinking about like whether the stators would be inside or outside as well. You got to have some way to get power to, like, electricity to the device, so that would be like through some of the supporting stuff. Yeah. Well, at any rate, this is a good start to this design and gives me something to tweak. It's always the hardest thing to do, to start a new design. Uh, and once you have everything set up and kind of parameterized, then it's easy to play around with it. And as far as other stuff that would go on this, like for the high detail version, there'd be like shield rings and stuff on this front surface for sure. Maybe a little bit on this back surface in the areas between the drives. There'd be other sensors and stuff attached. And then you'd have a nice big surface here where you could attach weapons. So probably weapons would sit, like sit on this front part. And then, fuel and ammunition and stuff could be kind of stored inside of this front surface. So yeah, I mean overall I like the silhouette of this, and it is distinct from my other stuff. So I think we've made some good headway here. So we've been going for let's see here, an hour and 45 minutes. So I think I'm gonna call it good here. The stuff as far as getting this into the game and into the lineup is not as interesting, I think, as kind of playing with the design and chatting about it. Thanks, Doug, for hanging out and talking about the design with me. That was fun to have somebody to think about stuff with. And I'll post some screenshots later once I have this in the game, in the lineup. Can compare it with some of the other ships and see how it looks. So thanks everybody for watching. This was fun. I like doing some live coding on stream, and I hope that this was encouraging to you in your own creative work, and I hope that you have good success in your creative projects over the next couple weeks. And Merry Christmas.